All right, so today we are talking about formulas. So if you can get out a sheet of paper, that way you can work out these problems with me, that'd be better. All right, so hopefully by now you have something to write with. So today we're talking about projectile motion calculations. Again, projectile motion is an object projected through space. It's an object traveling in two directions. We have the x direction, which is left to right, and the y direction, which is up and down. Remember, everything is still affected by gravity, which is negative 9.8. Again, there are two types of projectile motion, horizontal launch and vertical launch. Horizontal is just throwing something straight across and then it falling to the ground. Vertical launch is kicking something up into the air at an angle. So these are the four equations for vertical launch. Go ahead and write these four down on your paper. All right, these are the other three formulas you're going to use. Go ahead and write these down too. These are the same formulas we use with velocity in Unit 1. So the good news is we don't have to use any of the formulas dealing with trig. So we're not doing any cosines, any sines, any tangents. So don't worry about any of the angles. Now we're going to do some 4 practice problems. So again, this is where it starts getting complicated. So I want you to go ahead and number your notes. Number 1 for the first problem. I'll post these later so that way you can look at the questions, but right now I just want you to do the work with me. So before we start, I just want to remind you of a few things. The first thing is that anytime you see an X, that means it's your horizontal. Bless you. That just means it's your left to your right dimensions or your right to your left. I also want to make sure you understand what your Y is. Y is your vertical. And that means from your up to your down, or vice versa, it could be down to up. And the trick to solving these problems is to always draw pictures. When you visually see what's going on, it's going to help you better solve the problems. So make sure you're drawing pictures as you're working along, so that way you can see what you're solving for. All right, so for number 1, Bert is standing on a ladder picking apples in his grandfather's orchard. As he pulls each apple off the tree, he tosses it into a basket that sits on the ground 3 meters below at a horizontal distance of 2 meters from Bert. How fast must Bert throw the apples in order for them to land in the basket? So there's a lot of stuff going on in this problem, and I'm going to draw the pictures for you. So he's throwing the apples 3 meters below, which means you don't have to draw Bert. But he's about 3.0 meters above ground. 3.0. And then he's throwing him into a basket that sits on the ground at a horizontal distance of 2.0 meters. So that means the basket is right here. And you don't have to draw the basket. But that's about 2.0 meters. So he's on a tree that's probably on a ladder. You don't need to draw all that. But anyways, he's picking apples. And then he's throwing the apples into a basket 2 meters away. So that's what's going on in this situation. And we want to know how fast he's throwing those apples. So we're looking for the velocity because we want to know how fast he's throwing those apples. So that's everything we got going around. Now let's talk about a few things. The apple's going down. So what's affecting the apple automatically? What do you always know is affecting something that's going down? Gravity. So we still know that gravity is pushing down at a negative 9.8 meters per second squared. You always know that gravity is affecting it. So if you looked at the equations that you wrote down, you saw a lot of Vx, Vy, dx, dy. So we're looking for how fast an object is going. We're looking for a v. We need to figure out if we're looking for Vx or if we're looking for Vy. Before we solve that, I want to let you know that we always know something about Vy. So before it comes down, he's holding the apple in his hand above ground. What is the initial Vy velocity before he drops it? 0. Good job. Vy initial is always 0. So Vy initial is always 0. So you never really have to solve for Vy because we know the initial is always 0. So that means we're solving for Vx. So we're just solving for Vx. Now let's go back to our formulas. So we're solving for Vx. Which of these formulas is going to help us solve for Vx? The horizontal velocity one, the one that says Vx. Vx equals dx over t. Right off the bat, there is a problem with this formula. Does anyone know what we're missing? Yes, you're right. What did you say? Well, we know dx. Oh, we didn't talk about dx. You're good. Let's talk about dx first. So d stands for our distance, and we have two distances here. Which one's going to be my dx? Which one's going to be my dy? That's what you have to figure out. So 3.0 meters above ground, is that my dx or my dy? That's my dy. My y's look like my x's, sorry. 2.0 meters. Well, process of elimination, that has to be your dx. Okay, so now that we know our dy and our dx, when we look at our formula, we see that we're missing time. We need to solve for time first. So like I said, this is going to be a harder unit because you're going to be doing more steps. So we have to first solve for time. Let's go back to our formulas and see if we could find one that's going to help us solve for time. Which one can we use to help us solve for time? Yes, vertical displacement, the one that's t equals. All right, so y'all didn't see me draw this. I'm going to show y'all right now. All I did was put dy for 3.0 and dx for 2.0. And now we're solving for time, and we're going to use that one formula. Time equals the square root of 2 times dy over gravity. So we're plugging in our numbers. 2 times our dy, which is 3, Divide that by gravity. Now remember, when you have a square root, you never put a negative value under there because you'll get an imaginary number, and that doesn't work in physics. So we're just going to leave out the negative, and we're going to put 9.8 for gravity. So when you plug all of this in, 2 times 3 divided by 9.8, we have the square root of 0.61224. And then you square root that in your calculator, you should get 0.7825, and those are our seconds. So that was just the first step. We're not even done yet. We just solved for time, and that's what we're going to plug in here. So now we're ready for our second step, the actual formula that we actually need to solve the problem. So we're on step 2. Plugging in your numbers, we know we have a dx of 2 meters. So we're going to do 2 meters at the top. And we're going to divide that by the time that we just solved for, 0.7825. So I have 2 divided by 0.7825. When you plug that in, your answer should be 2.56 meters per second. So if you really look at it, it's not that hard. It's just time consuming. There's more steps now. But you've already used all of these problems, so you know how to solve it. So let's go to number 2. So go ahead and number your paper number 2, and let's start drawing again. A rescue pilot drops a survival kit while her plane is flying at an altitude of 2,000 meters with a forward velocity of 100 meters per second. If air friction is disregarded, how far in advance of the starving explorer's drop zone should we release the package? So we want to know how far in advance. And we know we have an altitude of 2,000 and a forward velocity of 100,000. What does the word altitude mean? Does anybody know what altitude is? Yes, good job. Sorry, were you going to say something, DeMarco? Okay. So my student in class said altitude means how high up in the air you are. So is that going to be my dx or my dy? My dy. So I'm going to try and draw a plane, but I can't really draw planes. It looks like a shark, but it's a plane. So my airplane is 2,000 meters up in the air, and we said that's our dy. So we know that we have a forward velocity of 100 meters per second. Is that going to be my Vx or my Vy? It's my Vx. Because we always know that Vy is 0, remember? So we're never going to solve for Vy. So that 100 meters per second, that's my Vx. And we're looking for how far in advance we're going to drop the package. So we're looking for this value. We want to know where that's at. That's our dx. So you don't have to draw pictures for every single problem, but if you are a visual person and you need to see what's going on, draw the pictures. I personally am a visual person, so I still draw pictures for everything. Let's go look at our formulas. So dx, x is horizontal, so we're going to look at our horizontal formulas. Which formula is going to help us solve for dx? Horizontal displacement. Good job. Dx equals Vx times t. Now, right off the bat, what's a problem you see? We need time. So I'm going to show you why this time won't work right here. T equals dx over Vx. We have our Vx, but we don't have dx. That's what we're solving for. So we can't use this horizontal velocity formula for t. So we're going to have to go back and use our vertical velocity formula for t because we do, oh, just kidding, Vy is 0. So we're not using that one. Does anyone want to take a guess which one we're going to solve to find time? Yeah, the one next to dy, vertical displacement. T equals the square root of 2 times dy over g. Technical difficulties. On a side note, have y'all noticed your scam likely calls have gone up a bunch lately? For the election, everyone's been calling. Who are you voting for? Anyways, sorry, sidetrack. So we're solving for dx. We know it's Vx times t, but we just said we need to solve for t because we don't have time. So we're going to use our time equals the square root of 2 times dy over g. So plugging in our formula, we have the square root of 2 times our dy was 2,000 divided by gravity. Remember, don't put a negative because we don't put negatives under square roots. 9.8. And again, this is the first step we need to take. So when we're plugging in everything to our calculator, 2 times 2,000, 4,000 divided by 9.8. We'll keep the 16. 408.16. Remember, don't round until the very end because that's going to change your answer. So try not to round to the very end. So when you square root that, you should get 20.20 seconds. But again, we're not done. This isn't the answer. This is just what we're going to use to help us solve for our dx. So now we could do our second step to solve for dx. Dx equals vxt. We know our Vx was 100. And our time we just solved for is 20.20. So 100 times 20.20, that's 2,020 meters since we were solving for distance. So again, these problems aren't that hard. The hardest part is figuring out which equations to use. All right, finally, our last one. In her physics lab, Melanie rolls a 10-kilogram marble down a ramp off the table with a horizontal velocity of 1.2 meters per second. The marble falls in a cup placed 0.51 meters from the table's edge. How high is the table? All right, so I threw in some extra information here. What don't we need to know at all? The mass, the 10 kilograms. Good job. So this is extra information put there to throw you off. We're not using mass because gravity is not affected by mass. Remember, no matter how heavy an object is, it's still going to fall the same. So don't worry about that 10 kilograms. We have a horizontal velocity of 1.2 meters per second. So is that my Vx or my Vy? Vx, because Vy is always 0. The marble falls in a cup placed 0.51 meters from the table's edge. So is that placed straight down or is that placed across? Across. Sorry. Yes, across. So is that going to be my dx or my dy? Dx. Good job. I want to know how high the table is. So what am I looking for? Your dy. Good job. All right, so if you want to draw it, you can. Again, you don't have to. This is my table. This is my marble rolling off of it. We know it has a horizontal velocity of 1.2, so my Vx equals 1.2 meters per second. And we know it drops in a cup. So this is my cup that's placed 0.51 meters away. And we said that's my dx. And we're looking for our dy. All right, so looking back at our formulas, which formula is going to help you solve for dy? Yes, vertical displacement, dy equals gt squared over 2. But again, what problem do we have? We don't have time. So we need to solve for time first. So the only other information we're given is our dx. So let's look at our horizontal formulas. Oops, those are not horizontal. Horizontal formulas, which one's going to help us solve for time? Yes, so time equals dx over vx. All right, so again, we need to solve for dy, so we're going to use gt squared over 2. But we don't have time, so first we're going to solve for time using our formula dx over vx. Our dx we said was 0.51. Our vx we said was 1.2. So 0.51 divided by 1.2, that's going to give you 0.425 seconds. And this time is going to help us solve for dy. So plugging it into our formula, g is negative 9.8 multiplied by time, which is 0.425 squared over 2. So when you plug it into your calculator, make sure you only square time. Do not square anything else. So 0.425 squared times negative 9.8 divided by 2. Your dy should be negative 0.885 meters. All right, now something to consider. I wanted to know how high the table was. Can a table be negative meters high? No. So when you're typing these in, you don't have to put the negative if it's asking you how tall something is. So if you type in 0.885 meters, you would still get the right answer. Again, it's just time consuming, these problems. You don't have to draw the pictures unless you want to. Most likely, you're always going to solve for time first, and then you're going to solve for another problem after.